Okay, so this is lecture 26. We've already been discussing a couple of problems. We're going to talk a little bit about problem 2005, show that every positive integer is a sum of one or more numbers of the form. And I believe I did things cleverly this time, so I could just quickly paste the, yes, there we go. And so the argument that was given was if you have some number n, if it's even, look at 2 times n over 2. And by induction, we know how to do n over 2. And then if odd, look at n minus 3 to the x, the highest power you can, plus 2 times s of n minus 3 to the x over 2. And notice that this is even. And so we can now write n as 3 to the x plus 2 times, some decomposition of n minus 3 to the x over 2. And clearly, we're not going to have any number divide any other number. So this proves the problem. But my question is, what about uniqueness? We know we can write, was it 5? No, 6 that you had? We could write 6 as 6. We're going to be careful because we can't use 1. Because 1 divides everything. So which was the first number you had that was not unique? 3. Okay, 3? No, 3 was unique.
Yeah, because you actually can't do +1.
Right, you can't do 2 plus 1. So if I want to do 1, the only thing I can do is 1. If I want to do 2, the only thing I can do is 2. 3, the only thing I can do is 3. 4, the only thing I can do is 4, right? 5, 2 plus 3, come on. 6 has to be, I can't do 3 plus anything. So 7, 3 plus 4, anything else work? I'm not going to have any 9 squared, sorry. 6 plus 1, no. 8, can't do 6 and 2, can't do 7 and 1. Right, but 5 is not of the form 2 to the a, 3 to the b.
Oh.
So 8 is the only way we can do 8 as just 8. So the question is it unique? So just something to think about. We've got 6 minutes left. I will earn my keep. I will choose a problem. I like 2003. So let n be a positive integer. How many ways are there to write n as a sum of positive integers? Oh dear God, this is a very tough problem. In general, we only have asymptotic formulas. But then they say such that the summands differ by at most 1. So we want to write them in increasing order, A1, A2, A3, A4. And you can be at most 1 more than the previous. So basically, we could have strings of 1s and then strings of 2s. Or strings of 2s and then strings of 3s. Something like that. And my first thought in trying to do this was to roll up my sleeves and count how many ways can I do with my smallest one is 1. How many can I do with the smallest is 2? So if the smallest is 1, how many ways? 1 way. If the smallest is 2, basically I have the floor of n over 2 ways. I can choose any number of 2s I want, so long as twice that is less than my number, and then I just add on 1 at the end. This is not looking pleasant. Right? This is not looking promising. Now, so they did give us 4. For the last problem that was done, there was actually a little bit of a kindness. They voted as 9 plus 8 plus 6. They gave you the decomposition. And they voted, again, they're going to write either increasing or decreasing order, and you see the 9, and you might notice, hey, 9 is a power of 3. And that might be a little hint for this problem that maybe you want to pull out a high power of 3. I would not have chosen 9 I wouldn't have chosen 23 as the number. I would have chosen an even number. I might have chosen 22 or something like that to try to hide exactly what you're doing. I think there was a little bit of extra information given there, possibly on purpose. So let's gather data. This is my default. I want to get data. How many ways are there to write the number 1 in a legal decomposition? One way. How about 2? How many ways can we write 2? I'm sorry? You can't do 1 plus 1. It just says all the terms, AK has to be less or equal to A1 plus 1. So there's 2 ways. There's 1 plus 1, there's 2. So 2 ways. What about 3? I can do 1 plus 1 plus 1. I can do 1 plus 2, and I can do 3. 4, we're told 4 ways. So we have some data now. 1 has 1 way, 2 has 2 ways, 3 has 3 ways, 4 has 4 ways. What do you want to conjecture? N ways. Do you see how valuable it is to just roll up your sleeves and do small cases? If you just start trying to do the problem like this is what my first thought was. Right? I start getting terrible formulas. But if I start doing small ones, I now have a conjecture. I conjecture that for n, there's n ways.
They kind of gave the answer.
So again, they want to make sure that you understand. And so they have to give you something. And you want to be very clear as to what's allowed or not allowed. So they gave you there's 4 ways. What's special about this? So conjecture.
You just said there are n ways. Would you get any credit?
You might get a point at most.
What's the point?
I'm not sure if they would give you a point because there's no proof of that. I don't know. They might give you a point. Conjecture. There are n decompositions. Okay. So how might we prove that? Okay. Any ideas on how you might prove something like this? Any idea of what technique? Induction, right? You have to hear voices. Any Simpson fans here? Listen to the voices in your heart, not the voices in your head, like one of your uncles did one gray September morn. Listen to the voices. When you see something like this, think induction. So assume we know it's true up to n minus 1. True up to n minus 1. Consider n. Any decomposition of n minus 1, we add 1 and get a decomp of n. Where do we add the 1? It has to be to the largest of the smallest summons. Add to the last of smallest summons. So if we had 2 plus 2 plus 2 plus 3 plus 3, this then becomes 2 plus 2 plus 3 plus 3 plus 3. And that gives you n minus 1 summons, or n minus 1 decompositions, but 1 new decomposition. All ones. So there are n. Now, is this a proof? Loosely. So I will leave you to think for next time. Is this a proof or is this not quite a proof? See some people shaking heads. That's not quite a proof. So I will let you think about that and just the need of being extremely rigorous.
With that script together.